there is a body of circular section which is rolling on a horizontal track with a velocity of u. That is given here, right? This body crosses a slightly elevated curved section AB, slightly elevated section AB, and it reaches point B in delta T1 time.
Sanikira.
So delta T1 time it reaches,
Pardon.
and there is no slipping anywhere, right? Now he's saying on the elevated section, the change in GP at any place is much smaller than the initial kinetic energy of the body. I'll consider this term afterwards. Now, he is saying if the length of the section AB, this total curve length, it is the good or the bad thing is that the shape of the curve is not given. That length is L. So the question is, if instead of rolling on this surface, if a body rolls on its mirror image track, so another track is given, which is the mirror image of this previous one, and you start from the same point again, the question says, if the same body enters the section CD, rolling with the same velocity u, how much time will it take to move from C to D? And obviously, sufficient friction is present everywhere, and G is also there. So there is no slipping in this problem. No slipping in the problem. The important thing in the problem is to think in terms of the only parameters which are given for u. I try to write the expression u term, that's fine. Delta T1, great. And you have to find out delta T2. So u is known, delta T1 is known, L length is known, G parameter is known, and we are searching for the time span delta T2. Right? Now, how can we utilize the symmetry in the problem? That will decide the solution. So there are a few things I'll do first before I write the final solution. First of all, I'll try to conserve the energy term. So let me think like this, the easier things in this problem. Let me think like this. So with respect to the initial position, let me try to analyze this body at a point where it has risen by a height of y. So because it is a body of circular section, by conservation of energy, I could have written that half I ICOR. So I am assuming that it had an initial omega naught, and at this position it has a general omega. So half I ICOR general omega square minus omega naught square, right? Or you can say omega naught square minus omega square, that is actually mg into y, mgy. And because it is a body of circular section, let me write I ICOR as some m into some constant into r square. Let me write this as mk r square type of term. I don't know the constant, not required. This much is fine. So my point is that I'll have a k by 2 term, I'll have a minus v square term, and a plus v naught square term, whatever, or u square, I should write. That initial velocity was u square term. That comes out as gy. Now here v and u, V is the velocity of center of mass at this height y, and u was the velocity of center of mass in the beginning. So by conservation of energy, I've written this equation, and this equation helps me in writing so it becomes minus v square plus u square is equal to 2gy divided by k, and that makes it v square is equal to u square minus 2gy by k. Huh, huh. So let me write this as my equation number 1. Now, remember, in the symmetric curve, I could have said that if in the same plane, whenever this guy reaches here, so it also comes down by the same y, right? Symmetrically, y in this problem is the magnitude of elevation or the depression. Magnitude of elevation or the depression, right? Vertical depression, vertical elevation. So my point is that, I mean, if the center of mass here has got a speed of v prime, I could have written my second equation as, v prime square should have been u square plus, it is plus 2gy by k. Everything remains the same. It should be u square plus 2gy by k for v prime square. यहाँ तक ठीक है? Now, up to this point, the thing is that I know the value of speed there, positive this much. I know the value of speed in the second case, which is this much, right? This thing. So now I think we can make some comparisons. My point is that if he is traversing at this place while he is traveling a differential displacement of ds, this guy is also traveling the same differential displacement ds. They are not at the same place at the same instance. Remember, these diagrams are not at a common time instance, because when he will be here, he would have already crossed this position. These diagrams are not at the same instance. So I'm analyzing with respect to same position, but not the same instance. Time instance would have changed, definitely would have changed. This much is fine. Now, so what I'm trying to say is, whenever he comes here and acquires a speed of v, that can be written as the ds that he will travel there upon dt. It will take some time while he will cross this place, and his friend, when his friend will cross this location at some other instance, he will also cross ds, but he will take some different time, which is dt prime. Good enough? Now focus on this first equation. So the differential time that he will take, the first person will take, should be equal to that ds upon root of u square minus 2gy by k. And I understand that what he will take. So remember, dt prime is also ds upon root of u square plus 2gy by k. Now again we are stuck. This is 2gy by k. Because the thing is, the time that he is talking about as delta t1 is basically the summation, I mean, the integral of this term, summation. And similarly, delta t2, which we are talking about, which we have to calculate, delta t2 is sigma of such terms. Let me just, instead of integral, one and the same. So these are the terms I want to add up, on that curve. So symmetry of the curve I have utilized already. And now I will use the fact that which he had given. He had already said in the problem that on the elevated section, the change in the gravitational potential energy is much smaller than the initial kinetic energy. This equation will help me because now I will take binomial approximation in the problem. Now this will become, it is sigma of ds term, check this carefully, upon u, factor of 1 minus 2gk 2gy upon k u square raised to the power minus half. Observe it carefully. Such terms I have to write for all the y's. And similarly, in this case, while I will write this term, I will write sigma of different ds's will come. So ds upon u, I'll have terms which will be like 1 plus 2gy upon ku square raised to the power minus half. And now there is a pattern if you observe carefully. After the binomial approximation, when you add, then that term which is different in both the expressions, that will cancel out. Because if you add delta T1, and remember this is not obvious at all. This statement that if you consider these two paths, well, I will give you wrong ways of explaining the answer. But there is no logic until unless you write the energy expression properly. You analyze the V, you take appropriate binomial approximation because that condition was being given that this 2gy upon ku square is very, very small in comparison to 1. Then this power will go off and then the term will become simpler because this term becomes twice here, this cancels out, and this term becomes 2, this becomes minus here, and this cancels out. And now you try to add the two terms. So for all the corresponding DS's, like DS1 at Y1, so he will also be at DS1, Y1, the same depth. So when you will add the two expressions, delta T1 plus delta T2, in RHS, you will only have 1 upon U is common. It is like 2 upon U times sigma of ds. That's what we'll get. This much is fine. That term is getting cancelled. Huh? And you're adding for every I, that term is cancelled. In the summation also, that will go off. And sigma ds, like he has assumed that this is not very, very highly elevated. So the total length was given as L. This becomes L. So the answer to the question which was required was what is delta T2? Delta T2 comes out as 12 upon U minus delta T1. I'll give you some wrong logics here to get the answer which doesn't have any significance until and unless you write. Like saying this thing that when we will cross these sections, the acceleration, the wrong way of writing is, I could have said that if I observe here, the acceleration, the retardation down A and the acceleration here is same. Good. Then what? So if I start writing like this, I'll tell you method 2. This won't end me because that only means that if I want to write dv by dt at one place, and the second guy will have dv prime by dt prime at the same place, and the sum of these two terms is 0. That is not helping me out because dt is not common. Na? This doesn't lead me to d by dt of v plus v prime is 0. Because at the same location, he comes at a different instance. I go to the same y location upward at a different instance. I took my time dt. He took his time dt prime. My change, his change. This equation is fine, but not helping you out. You can try. First, Another student can say, sir, I will write, okay, this is not leading to any location. So another student says, I'll write this equation, B. He says that if you observe carefully, the decay of kinetic energy in first case, total, and the increase of kinetic energy in the second case is the same. है ना? क्योंकि mgy है तो जितने से काइनेटिक एनर्जी कम हुआ है ऊपर जाते वक्त उतने से वहां बढ़ा है. Fine. And all the kinetic energies can be written as half I ICOR cut down into omega square, and ICOR will be k into r square. So basically it will be some constant into u square term. So I could have written k into what? Upper decay. So u square minus v square if the velocity here I've written as v and the lower term I've written as v prime. So I mean this can be written as k times v prime square minus u square. That's fine. This will cancel. This will give me 2u square is equal to v square plus v prime square. This is also correct. This is also correct. This equation is also correct. This one is also correct. But think, I mean, they are not leading you towards anything. I mean, if I make a multi-correct problem, I can use such options. So, I mean, through energy, this equation comes up, but this is not helping me in finding out time at all. Through the acceleration, tangential acceleration, I'm getting these terms, that the tangential accelerations there are equal and opposite. So, मुझे ये भी मिल रहा है. But still I'm not getting that. I mean, ratio, even if I write, it comes in terms of dv and dv prime. And that term again, I know here, but this becomes the same. If I take d of this equation, this becomes d of 2u square is a constant. So d of v square plus v prime square, that term is also known to me. So it's like v dv plus v prime dv prime, that is equal to 0. So these are different equations which you know. But because v upon v prime, this is not coming out to be constant. You can try. Even after writing these equations, you won't be able to find out that sigma term. आएगा नहीं वहां से. So maybe in a multi-correct, these things he can put up, but you know, you have to follow this symmetry of the function and that condition that the change in GP is small in comparison to the kinetic energy, initial kinetic energy. Serious about the concepts of impulse, right through the concept of impulse. Problem is somewhat like this, that there is a homogeneous plank and there are lot many rollers. Now, a homogeneous plank of mass capital N and length capital L is gently released on an inclined rolling mill, which consists of a large number of uniform horizontal cylindrical rollers. These are uniform solid cylinders, right? These rollers which are given here, they have their respective axles and they are not touching each other. There is a subtle gap between them. Okay? And the question is, if the axes of the roller are fixed parallel to each other in a plane which is inclined at an angle theta, and they are separated by small l, very, very small in comparison to capital L, between two adjacent axes, and this is also given that the mass of a roller is m. ये सब ठीक है. Everyone can rotate about its axis without friction. Acceleration is long time after the plank is released. If it acquires a steady speed v, can we find out that steady speed? That is the point. So lot many rollers were there, and your plank was released. It kept on moving downwards by virtue of that tangential acceleration, and ultimately it acquired a steady speed. So if that acquired steady speed is unknown, we need to find out the expression of the steady speed. Okay? All right. So for the sake of simplicity in the problem, let us analyze it in that state only. Let's say steady state has been achieved already, and that steady state is being V. and I'm genuinely looking at the instance where it is just crossing the tip of one of the rollers. That instance only where it is crossing the tip of one of the rollers. And that time speed is V. Now, actually, if you look into the phenomena, there are two things which are happening. Whenever it strikes a roller, there is an angular collision between the plank and the roller. So what I'm trying to say is, whenever the impact happens, let's say, I mean, if I started from this place, I'm trying to observe it here. So whenever, or let's say this is the impact only. At that very instance when the impact happens, at impact between roller and plank, the impact wale instance pe, what are the equations we can write? Think of the impulse and the angular impulse. So it seems ki I will get a impulse in a direction opposite to V. If that impulse there is, let's say, f dt minus f dt type of term, that will change the momentum. You know? So that will make it m v prime minus v term. So that is my equation number 1. My velocity just before the impact with the roller was v. You know? It was v just before impact. And I am saying, try to observe it carefully. I'm saying just after the impact, it becomes v prime. V prime is less than v. That's what we are saying. Because of that frictional impulse in the tangential direction, my velocity reduces suddenly. But at the impact instance, this impulse is imparting an angular impulse to the roller also. So to the roller, who was at rest, because this plank is just touching it, so the roller, which is just being impacted at the frontmost end of the plank, with the impact at the frontmost end, there the roller will suddenly get an impulse, and that will provide an angular impulse, which is f dt into radius of the roller, and that will be I omega. So small m r square by 2, it will acquire omega prime. Let me write it as this, omega prime. Will acquire omega prime. And this thing is also right, that by constraint relation, that v prime is also equal to r omega prime. This v prime should be equal to r omega prime. Suddenly, that velocity will be acquired. Now let us just try to, sort it out. So, I mean, after cancellation, this becomes small m by 2 v prime. And all these equations help me in finding out. So this is 0 is capital M v prime minus v term is there. And I have got a positive small m v prime upon 2. Seems like I'll get my v prime in terms of v from here. This capital MV upon capital M plus small m by 2. This is the velocity. Now what we are trying to say is, when he is saying that there is a steady velocity which he has acquired, actually there's a discreteness in the motion, but that discreteness is over an interval which is very, very small, so it seems like a continuous steady motion, right? So, I mean, if you write the fourth equation there, so again we will say that, okay, after the impact, it reduces, but from that impact to the next one, the consecutive one, it will increase its speed. So directly I'm writing under some approximations. So I will say, I will again increase my speed to v. So v square just before the next impact will be equal to the previous just after impact, v prime square plus 2as. So that term is 2 g sine theta multiplied by the displacement, and that displacement there is small m. Definitely, I have taken this approximation that small l is very, very small. and those masses which are there below does not play any significant role while writing the expression of A, acceleration, right? Now, from these two equations, if you substitute, I think you will get the result. So just I will write something here. What is required is V, fine. So V square into 1 minus. So V prime square is M upon M plus M by 2 the whole square, and that is coming out as 2G sine theta multiplied by L. And take binomial term on this. This should be V square. Remember, your answer to the question is V. Answer is V, right? So V square 1 minus, what is that term? Small m by 2 capital M and raised to the power minus 2. So it is 1 minus small m by 2 capital M minus 2. Just check, is this the right term? And RHS I'm getting as 2GL sine theta. Yeah? That is 2 small m by capital M. So effectively your V should come out as root of 2GL sine theta. I think it should come out as root 2GL sine theta, 2GL sine theta into capital M upon small m. And root 2GL sine theta into capital M by small. So while writing that energy equation term, you understand, I have assumed that the rollers have not changed their kinetic energy by much because that distance is very, very small. It is just that this discreteness of impulse, angular impulse, which is to be catered properly. Rest in the problem is fine. Okay, let us move on to the next problem for the day. The problem was like this, that a boy is driving a bicycle. Lot of these type of problems in circular motion are also there, and primarily this is in attachment with rotational mechanics. So when a boy is driving his bicycle at a constant speed on a circular path on a horizontal ground, to do so, he turns the handle. You want to turn on a circular path, so he turns the handle so that the front wheels makes an angle of theta with the line joining centers of the axles of the wheel. Distance between the axles, that is given, theta term is there. Now, if the coefficient of friction is same between both the tires and the road, just take care of the data. You have to find out the minimum mu between the road and the tire so that the cycle does not slip. And a minimum mu between the road and the tire so that the cycle does not slip. And assume the center of mass of the cycle and the boy as such, net, that is equidistant from both the axles, and G is given. So the first thing to begin with is to look into the top view of the cycle, top view, and just try to observe the two tires along with the axles. This is a rear tire, axle of the tire, axle of this wheel rather, and this is the front one, front wheel, correct? So although if you look from the transverse cross section, there will be this triangular frame structure along with the boy who is sitting on the bicycle. So the combined center of mass will be somewhere above these two axles and midway also. But if you look into the top view only, you can see only the lateral distance along the horizontal plane. So I'm just drawing the location of center of mass accordingly. This is from the top view. It is not on the same line, rather it is forming a triangle. अब वो क्या कह रहा है? If the distance between axle is L, this point, so we understand these distances are L by 2. This distance here is also L by 2, right? And for both the axles, just look into forget about the tires and the wheel. Look into the rigid structure. The center of the rear wheel, the front wheel, that is a part of a single rigid structure. Forget the rotation of the wheels. For the single rigid structure, the direction of the ICOR is perpendicular to the direction of the velocity. So this guy will have velocity here. It's normal. This is having velocity here. It's normal. So this point is behaving as my center, ICOR of the structure. And the rigid structure, the center of mass of the rigid structure is moving about, because now it is a single rigid frame. So it will also move on this about the same IAOR. I can say this axis here is IAOR. We'll have some radius, call it R. Right? So maybe the rear wheel, the front wheel, and their respective radii R1 and R2 at this instance. All good. Center of mass will also have a velocity at this instance, which will be along this direction, V, which is perpendicular to its respective radius, R. उसके normal होगा, omega सबका एक ही आ जाएगा. So keep this term as such and just stay with the data which is given. Like the front wheel makes an angle theta. So this angle here is theta. So the normal, so this angle here, the total angle will also be theta. ये भी ठीक है. So few distances are very clear. This R1 is coming out as L cot theta, है ना? And R2 is coming out as L sin theta. Just check that. All good? L पता है, theta पता है. So these radii are known to me. Right? Where is that? L? L upon sin theta. L upon sin theta, L cot theta. This much is fine. Now let us draw the forces which are acting. Free body diagram. So seems like यहाँ से एक N2 will come. This point, I'll have a normal reaction N1, and at the center of mass, I will have the mg term. And now the friction terms. So on the rear wheel, I'll have my FS1 here, FS1. On the front one, I will have a FS2, which is normally inwards. So you are supplying that energy to the rear wheel. The rear wheel is having a static friction along the tangential direction, providing a tangential acceleration. And he is just trying to handle, by virtue of the turn which you are providing here, it is only having a tendency of slipping, so it will have a friction, static friction, FS1. Now, one more thing that, so if I take all these forces, I may have to write equation for center of mass, but let me get into the C frame. So I'm just trying to get into my C frame. So it feels like this term, I mean, I will have a component mv square upon r radially outwards on my center of mass. Now, if you look into the forces which are coming out, and there are two things which are very clear, like N1 and N2, both are equal to mg by 2. This is our first equation, seems like. Because if you look into the wobbling, right? You get it. If you look into the cycle, it is not getting wobbled. You know, ऐसे नहीं हो रहा, like a ship. So that's why I balance the torque of N1 and N2. Both the lever arm is L by 2, so N1 is equal to N2. So that torque balance and that force balance, few things, that the simpler things, that gave me mg by 2. Now come into the talk about the forces in this plane. So if I apply polygon law of vector addition, look into these three vectors. I mean, triangle ही बना लेते हैं. So basically seems like fs2 vector is along this side and mv square upon r vector is along this side. Definitely the vectors should be like this only if you want these vectors in the plane to give me a zero resultant. And remember, this triangle of vectors should be similar. So this side, this one, this segment here, and this guy here, and this guy here should be in the same ratio. It should be similar triangle. That means now I'm in a position to write these values. So Fs2 is to Fs1 is to mv square upon r should be equal to R2 is to L by 2 is to R is to R. So that was my first equation. Now we understand that we have to write boundary condition. I mean, we have to write that condition of no slipping on Fs1, Fs2. Now we are in a position to solve for Fs1, Fs2 both. R is also a known parameter. Now, so just if required, R square is L square by 4 plus L square cot square theta. If required, you can use it. अब देखो एक बार. So write this equation number 2 or try to just write the equation required, because mu is greater than equal to, just look into Fs1 and Fs2 and tell me which one has got a higher value from that ratio wala equation. So R2 and R. बड़ा है R2 है ना. So R2 is greater, so that means R2 and L by 2 rather. R2 is greater than L by 2 also, ना. So Fs2 बड़ा है. So that means the mu which will be demanded by Fs2 will be higher. So if you justify that, so I think the answer to the question should be finally mu should be greater than equal to Fs2 ka value divided by N2. That will also justify the other condition. You're getting about now? I have to check mu greater than equal to Fs1 by N1 into R equal. Fs1, Fs2 में से Fs2 बड़ा है. So satisfy this, you'll get your answer. So basically, the minimum mu, this inequality is your answer. Now N2 is mg by 2 और आपको क्या लिखना है? Fs2. So Fs2 is something which you need now. So now use the required equation. So Fs2 upon mv square upon small r, that will be equal to R2 upon R upon. Your Fs2 becomes mv square R2 upon R square. mv square R2 divided by R square. Just follow this carefully. Now mm is fine. R square you have to substitute this value. Only thing is where R2 expression you just write down, I think that was also known, is L by sin. Just substitute everything, you should get your answer. So that final result for mu greater than equal to, that will come from this equation, right? So further you can complete the problem. Let us move on to the next problem. Now, these are very conventional ones. Next one that I am taking. Important from JEE's perspective also. Just have to carefully put down the data. थोड़ा सा change किया इसने from a standard problem. Just go through the data. तो बोला stationary point source creating a potential field is at the origin of a coordinate frame, and the potential energy of interaction in this problem of the source and a particle of mass m इसको दिया हुआ है with the equation minus k upon r raised to the power 4, where k is a positive constant, r is the distance of the particle from the source. कहता है कि if the particle is projected with the initial velocity u from an infinitely distant point, distance between the initial line of this is B. What should be the minimum B for this projection velocity of the projection velocity so that the particle does not hit the source? What should be the minimum value of B for this U so that it does not hit the source? So, okay, we are going to conserve the energy. We will talk about conservation of angular momentum. But what is the condition you think we should write to solve it? It is a case of attractive field. So U negative diya hua hai. So it's attractive force field. Some path it will follow which I am not interested in. And I don't want this particle to hit the source. That means one thing is clear, that whatever path it adopts, it crosses from some nearest location, not hitting the origin. So when it crosses, just draw it carefully, when it crosses from that position, I mean, if this point is O, right? If the field function was known, we know that the path would have been ellipse, hyperbola, or a parabola, which is not the case here because the function is different. We have already derived those curves earlier. Uska curve to derive karne ka zarurat nahi hai. But whatever it is, let it, if it is not hitting, let it pass from this point. Let me call it as R prime with some speed V prime. This is kind of the minimum distance. Okay? Jo zero nahi hai. That's what he's saying. So if he is crossing from this point, then I can conserve my energy. So I have got my half mu square term. Initial potential was 0. I have got a half m v prime square and a potential which is k upon r prime raised to the power 4. It is fine. And these are the two conventional equations I could have written. U into B, I mean U into B, that is v prime into r prime. ये दो बातें तो ठीक है. Now, from these equations, जो condition है वो B पे निकालनी है ना? So the thing is, you could have written these equations as mu square upon 2 term is there. That makes it m by 2. This is ub upon r prime, the whole square, and minus k upon r prime raised to the power 4. This becomes mu square multiplied by 2 r prime raised to the power 4. So r prime 4, this is m u square b square r prime square and minus 2k. Minus 2k. That makes it m u square r prime raised to the power 4 minus m u square b square r prime square plus twice of k. That is equal to 0. And I need a root of this equation. For such a situation to be possible, I need a root for this equation. And that leads me to a situation where discriminant should be greater than 0. So indirectly, I am now leading towards that condition that minus m u square b square whole square, that is greater than 4 mu square 2k. So 8 mu square k, it is 8 m u square k. So I think it is m square u4 b4 is greater than 8 m u square k. So m square u4 u square term. So the B condition which is demanding seems like B4 should be greater than 8k upon mu square. It is 8k upon mu square, and that is leading us to this situation which is 1 by 4 8k upon mu square. So even while the projection happened, at that state you have to have inequality on B for this condition to be satisfied. So will not hit का मतलब यही था कि आप assume कर लो that it is not hitting and then just think that there should be a root to that equation that will serve my purpose of inequality on the path derivation and everything we have already studied. By energy and momentum only we can write the equations which lead us towards the path. So this was the fundamental point in this. Now again, lot of information regarding collision an angular impulse. So just be careful as you read the data. There are two identical uniform disks. Each of them is having a mass of m and a radius of r. They are given, they are placed on a horizontal frictionless floor. One of the disks is given an angular velocity omega about a stationary vertical central axis. Stationary vertical central axis. And the other is projected with a horizontal velocity u without rotation for a head-on collision to occur between them. Clear है? ऐसा लग रहा है that these are flat disks, and this flat disk is rotating with some omega. Generally, in these problems, we are solving problems like this. Here, the problem is in this plane, and the other one is slipping straight into this. ये भी दिया हुआ है. So, क्या data है? Let us put down the data properly. For a head-on collision to occur between them. If the collision is perfectly inelastic, let's see what happens here. And the slipping between the disks ceases in the end of the collision. This information also you have to crack down. You have to find the angular velocities of the disk and the speeds of their center after the collision. So we need to solve for these two things. ठीक है? अब करना एक बार देखते हैं how you write the angular impulse and impulse equation. So I'm assuming the just before collision instance like this. क्या मान रहा हूँ? I'm assuming that this mass m, uniform disk m r, it is having some omega anti-clock, and the other person is about to hit it, and the collision is head-on. So I mean, the impact line is also the line of action of velocity. So he is coming with a velocity of, this is the initial state, just before the collision state. You sure? So what are the things we should write? Well, there should be some friction between them, because that will impart something. So it seems like that just after collision, this guy will have something in the downward direction. तो जनरल लिख रहा हूँ अभी मैं, बाकी देखते हैं फिर. Will have some v1, and right in this direction, let me take it as vx1 maybe, and this downward direction I'm taking as vy1. And it will also acquire some omega. So this is body 1, this is 2. It will acquire omega 1 in this direction because of the frictional impulse, angular impulse of friction. Right? As far as the front body is concerned, its omega seems to decrease to some omega 2, maybe in the reverse direction also. It will acquire something here, that is a vx2 velocity in the forward direction. And so when the impact happens, क्या लग रहा है? He is imparting friction on this person in the downward direction, so upward. So seems like it should have something here, maybe vy2 type of final velocity. So a lot of parameters are there, these momentum parameters, and there are few equations which are obvious. Both of them were identical. So few things, I mean, there are 2-3 equations which are direct. Then just apply the thought in the problem. So mass I am ignoring directly. So I could have said that u term seems to be vx1 plus vx2. We will look into possible conditions also, so don't worry. Okay? And similarly, it seems like vy1 is equal to vy2. That is also fine. And you can conserve the angular momentum also. So about which point you are conserving and what are the terms you want to write. So let us just focus on those terms carefully. There are few parameters which will reduce out of these things. There are other things also which he has given. He has already said that the collisions seem to be perfectly inelastic. Let us write that condition also. So along the line of impact, the separational velocity is 0. So Vx2 seems to be Vx1. Yeah. So Vx2 is looking like Vx1 in this problem along the that line. And fourth, even if required, we have to see, I mean, is it needed for me to analyze specifically for angular impulse? Then I can write few equations, or directly हो जाए तो वो भी अच्छा है. So I am just observing and writing. You stay with the problem. What I am trying to say here is, as I will get that n, I mean, I am having this n term, and I am having that friction term on this person down, and the friction term here up. As far as the momentum part is concerned, we have already written. So let us just focus on to the angular impulse. So I want to write the change in the angular velocity, because I is common, angular impulse is common with proper direction. So final anticlock I am taking as positive. So I mean minus omega 2 minus omega, that should be equal to angular impulse. And if you look into the magnitude here, so treat it as clock as positive. So that should be equal to omega 1. Is that fine? I've written the angular impulse of F on the first guy, treating this clockwise as positive, और उसके लिए anti-clock as positive, and magnitudes are equated, magnitude anti-clock and the magnitude clock. So I have taken the correct signs. So this is one we could have written through the angular impulse part, which is there in the problem. So these are the 4 equations which are directly coming. Now you think. One more information is given. If you read it carefully, he has given this fifth. Further, I will write angular impulse, don't worry, as per requirement. But let me finish off the fifth information first. What is that? He says that the question is, the slipping between the discs ceases at the end of the collision. So as the collision has finished off, there is no relative velocity at the point of contact. There is no slipping. So what does that mean? So, I mean, Vy1, if the radius is r, plus r omega 1 plus r omega 1 should be written as, this is down, that is r omega 2 minus Vy2. That is also all good. Now you check all the equations I've written. I have taken E0. I've written the equation for no slipping at that place, right, in the final state. Momenta x, y, I have looked upon. Angular impulse, I have looked into. Even the individual impulse quantities in x and y, there is a relation between impulse and angular impulse also. Now, one more relation is there. Because wo mu term must be there. So you understand, there is an impulse angular impulse relation. Na? So that we have to write. So any one of them. So let me write that sixth one. Piyusha, batana. What is your sixth equation? So maybe when you have given impulse to this person n, but then mu is not given, no? Perfectly fine. So F and F's angular impulse. So angular impulse of, maybe let me take the easier person, this one. So angular impulse of F and impulse. So angular impulse of F on 1, I'll directly write, that is impulse. Impulse is mvy1 impulse into radius, that is angular impulse, that is change of angular momentum. So that should be m r square by 2 omega 1. I think that should work. Check. I can write similar equation for other person also, But I think in the overall scenario, that thing would have been included, not required. You got this point, no? मैंने बस ये देखा था कि while I'm just thinking about F, the impulse that F has provided to 1 has changed its momentum downwards by V by 1. The impulse is mv by 1, mv by 1, this much. So angular impulse of F is mv by 1 into r, and that has changed the angular momentum. So that should be this. So there is an inherent relation between v by 1 and omega 1. They are not independent quantities. As if somebody says that if you think of 7th equation here, similarly, the impulse that F has, angular impulse that F is providing, that is mr square by 2. Just observe, mr square by 2 final. So check this final. This is clock now. So final was minus omega 2 minus omega angular impulse is equal to, okay, this is change of angular momentum that I have written, and that should be equal to r into linear impulse of F. The linear impulse is m v by 2, m v by 2. This is the counter equation for 6. But both must not be required because already I have used those equations. You got the point, huh? Impulse, angular impulse term. So the point is, when you have already written the angular momentum conservation, so writing it at one place is sufficient because as a system you have already considered it. So they are not independent 7 equations. I've used one equation already. बात समझ लो. Otherwise, write independent equation for individual body. Don't talk about system. Still, you will get it. So this was actually important, the last equation. Otherwise, there will be scarcity of 1. We are already in excess of 1 because we have used all the data. So not required. 1 will be linearly dependent equation. You can check once you solve. 2 things which I like in this problem is generally we keep on solving problems which are in a vertical plane. This was in horizontal plane and data was given in a different way. You have to analyze everything categorically. So from an advanced perspective, maybe in a multi-correct and independent equation form. This is also becoming a current trend that any good problem which they think that the calculation is very lengthy, they are putting the equations in a multi-correct format to understand your thought. So these 7 ideas can be put up in some way in a multi-correct problem. So always they are not thinking in terms of calculation. So you have to be careful. Okay, fine. So I'll stop the class here and we will take up more ideas in tomorrow's class. Take care and good night to all of you.